Hello everyone, welcome to 8-16. On our today's lesson, I'm going to explain how we are going to just describe these different problems. That means in this case, I will explain what is the meaning of differentiating and how we are going to determine the coordinates of the stationary point, and again, if the gradient or the slope of a line to the curve is already given, how we are going to determine the values of y or the coordinates of y. So generally, on our today's lesson, there are some very important points here. So if you want to know more about this lesson, please try to just have a notebook and follow and listen carefully, and I'll explain every point, even that is not stated here. So if you are a new member of my YouTube channel, don't forget to share, like and subscribe 8-16, because if you share, like and subscribe, you can have more videos and you can get more concept about what I have already prepared for IGCSE level students. So let's come to the first problem. What is differentiated? What is differentiating mean? In the first illustration it says differentiate. It says differentiate. Differentiate mean what? Simply the meaning for this is what? Differentiate mean we need to find the derivative of the given algebraic expression. Here as you look, all these are algebraic expression. That means x cubed minus 2x squared plus x is an algebraic expression. 6x raised to 4 minus x raised to 5, 6 plus x minus 3x squared. All these are simply algebraic expression. These are algebraic expression. That we call these are an algebraic expression. So how we are going to differentiate this problem is that how we are going to differentiate this problem mean how we are going to determine the derivative of all these problems. Is that in order to find the derivative of all these cases, first of all, let me just show you how we are going to solve this problem. Is that so? Let me clear and let's follow how I'm going to do. So for the first problem, as you have already seen, first you have to say, now you have to say to find the derivative of this problem, you have to say let y is equal to x cubed minus 2x squared plus x. Is that? So at the very beginning, you have to say, before you solve this problem, you have to say y is equal to x cubed minus 2x plus x, because now this is obviously function. Is that? So how we are going to differentiate? How we are going to find the derivative? Derivative mean, as you know, as I have already just said before in my previous video, the derivative of the function mean it is always the gradient of the curve of the function, or the gradient of the line tangent of the function at the given point. Is that? So that's the meaning. Therefore, to find the gradient or the derivative of this problem, it is given by dy by dx, as we call this is differentiating. Is that? So now if it is a polynomial, that can be written as I have already shown before. For example, if there is a function x raised n plus x raised m, because if you want to know more about this one, you can look my previous video that is already done based on like this one. Is that? So to determine the derivative of this problem or the derivative of this expression, now always n, the exponent should come as a coefficient, n times x raised n minus 1 plus m times x raised m minus 1. Is that? So this is the derivative of this kind of function, or for this kind of problem, for any polynomial function, this is the way. Is that? So in order to find the derivative of the first, these algebraic expression or the first system, we need to describe 3x squared. Is that? Because 3 should come as a coefficient and we need to subtract 1 from 3, and we have this minus 2 times 2 come as a coefficient to x raised 2 minus 1 is always what? That's 1 plus the derivative of this is simply the coefficient. The coefficient is already understood, which is 1. That means if we have a function that is written as kx, so dy by dx is always what? this is always k. That so simply the coefficient. If the degree or the power for the function is already 1, or it is degree 1 equation or function, now the gradient of the derivative will be the coefficient. Is that so? With this principle, now the gradient of this is immediately this one. So this is how we are going to differentiate for the first problem. Is that this is how we just find or differentiate the first problem. Let's come to how to differentiate the second problem. Is that how to differentiate the second problem? Now, for the second problem, you have to say let y is gonna be what? 6x raised to 4 minus, which is x raised to 5. So similarly, or with similar procedure, to find the derivative of this one, simply immediately divide by x is gonna be what? 6 times 4x raised to what? 3 minus 5x raised to 4. Always the exponent for the terms should be decreased by 1, and those exponents should become as a coefficient, and this is 24x cubed minus, which is 20x raised 4. I think if you want to put this in more simplified form, you can put this or you can describe this as, you can take out the common of 24 and 20, that is 4x cubed into 6 minus immediately 5x. Is that? So we can factorize this way. Is that? So this is the way how we are going to describe second problem. Let's come to the third problem, how we just find the derivative, or how we are going to differentiate the third quotient. The third just expression or function is y is equal to 6 plus x minus 3x squared. Is that? So how we are going to differentiate this problem? In order to find the derivative of this function, to find the derivative of this problem, immediately you can apply dy by dx as given by the derivative of any constant is 0. So this is 0. The derivative of x, as I have said before, it is simply 1 minus the derivative of this problem will be 2 should come as a coefficient. So 2 times minus 3 will be 6x raised 1. This is written this way. So this is simply how we are going to find the derivative of this problem. Well, now when you come to in the case of this problem and this problem, what you're going to say? Now for question number 1, it says find the coordinates of the stationary points of the curve. This one is that, first of all, let you know what is a stationary point. Is that what's the meaning for stationary point? Then if you know what is a stationary point, this is very simple to find this stationary point. First of all, let you know how we are going to describe, or how we are going to just evaluate the stationary point. Therefore, a stationary point means, in order to find the stationary point of any function, at the very beginning we need to find the derivative of this one. That means dy by dx, as I have already just shown before, it is going to be 3x squared minus 4x plus 1. Is that? So the derivative of this function will be this one. Is that? The derivative of the function with respect to x is given by this one. So in order to find the stationary point of any curve, stationary point for the curve mean we need to find the turning point of the function. Is that? What are the turning points of the function? So in order to determine turning point or stationary point of any function, so first of all we need to find critical number of the function. The critical number mean simply we need to find the zero of the derivative. Is that? The zero of the derivative mean now we need to equate these as, first we need to solve this problem just like this. 3x squared minus 4x plus 1 should be 0. Is that? Now in order to find the stationary point for the function or the curve, now stationary point is always calculated when we are equating the derivative with 0. Is that? So first we need to equate the derivative with 0 just like this way. Then let's find, or let's determine the value for x here. So here as you look this one, this is quadratic equation. In order to solve a quadratic equation, at the very beginning, let us consider two numbers whose sum is exactly the coefficient of the middle term, that is -4, and whose product is always AC. What is AC mean? A is already 3 and C is already 1. 3 times 1 will be this one. We need to find two numbers whose sum is the coefficient of the middle and whose product is the product of AC. 3 times 1 is 3. So what are the numbers? So obviously the two numbers whose sum is this one and whose product is this one is -1 and -2. Is that? So if you find the sum of this one, the sum of this will be this one and the product of this will be this one. So if this is so, how we are going to just calculate, how we are going to determine the value for x. So this can be written as, generally this is written as, so once we got the two numbers whose sum is this and whose product is this one, immediately we can factorize this as x minus 1 into x minus 3 is equal to 0. This will be the factorization of this one if and only if the coefficient of the leading term is 1. But here the coefficient of the leading term, this is different from 1, that is 3. If that is so, we need to divide this coefficient for 3 and this coefficient for this one. That means we need to divide this for 3 and this is for 3. And this can be reduced or factorized as, let's bring here, and it is gonna be what? It will be written as x minus 1 over 3 into x minus 1, which is 0. So x will be 1 over 3 or x will be 1. So this is the value for x. Is that? So if this is the value for x, how we are going to determine the stationary point? The coordinates of the stationary point will be, now we have to plug this and this one directly to the original function. So as you know, the original function was this one. Let me come to the original function. The original function means y, which is immediately given as x cubed minus 2x squared plus x. Is that? So this is the original function. So to determine the stationary point, so these are the 0 for the derivative. So the coordinates of the stationary point are always existing on when we are equating the derivative of the function with 0. Is that? So now this will be when we plug 1 over 3 here, y1 will be 1 over 3 the whole cube minus 2 into 1 over 3 the whole square plus 1 over 3. Is that? So now this is exactly what? 1 over 27 minus this is 1 over 9. So 2 over 9 plus 1 over 3. And let's just take LCM of all this is 27. 27 divided by 4 this, that is 1. 1 times 1 is 1. 27 divided by this, it is 3. 3 times this is 6. 27 divided by this, 9. 9 times that will be this one. And this is going to be 10 minus, which is 4 over 27. Is that? So one coordinate point will be this one, and the other y2 mean y2 is obtained when the value for x is 1. So let's plug 1 immediately. 1 cube minus 2 into 1 the whole square plus 1. Is that? So this is immediately 1 minus 2 plus 1, which is immediately 0. Is that? So therefore now the coordinates of the stationary point are what? Therefore, the coordinates of the stationary point, pointers are what? Pointers are where x is 1 over 3, comma what? 4 over 27, and when x is 1, our y value is 0. So these are the coordinates of the stationary point. See that? So now this is the value of the stationary point, the coordinates of the stationary point from the given problem. Is that? So Well, now let's come to the third problem, or the last question. When it comes to the last question, what it says the last question mean? So as you look, find the coordinates of y here. Is that? Let's determine the coordinates of y when the gradient of the slope. Slope means simply the gradient. Is that? The gradient. You know, gradient means it is an angle of inclination of the line from the horizontal surface. In the case of the function, the gradient of this function means, for example, if the graph of this problem is going to be like this way, now we can find the gradient of the function at any point. For example, there may be a tangent line here, or the tangent line there may be around here, there may be another tangent line. So whenever we find the gradient of this tangent line to the curve at this point, we call that is the gradient of the derivative of the function at this point. Is that the derivative of the derivative of the function at this point? So we call the gradient of this line tangent of this at this point mean it is simply the derivative of the function at the given point. So and hence, how we are going to determine the coordinates of y when the gradient of the slope of this is exactly this one. So first of all, we need to find y by the x. Is that? What is y by the x? Y by the x means immediately you have to find the derivative of this one. As I have already shown before, the derivative of constant is 0. So derivative of x is 1 minus 6x. Is that? Derivative of this is 0. Derivative of this is 1. Derivative of this is 2 will come here. 3 times 2 will be 6x. And 2 minus 1 is 1. So it is written this way. And therefore, the gradient, we call this is the gradient of the function at any point. Is that? At any point. So the gradient of the function at any point is particularly given by 90. Then how we are going to determine that point, or the intersection of the line and the curve? Is that? So to determine the intersection of the line and the curve, now it is done this way. Is that? So this implies that 1 minus 90 is going to be, you can move this on the right, that is 6x. I have bring this on this side and I have moved this on this side. Is that? In different direction. So I have moved one term having the variable on the right and the constant to the left. Then the 1 minus this is negative 18, and which is 6x. This implies that x value will be negative 3. So when the value of x is minus 3, the question is, what is the coordinates of y when the gradient or the slope of this is this one? So we have to directly plug what? We have to directly plug this x value on y to determine y value. That means, therefore, what you're going to do, y is going to be 6 plus minus 3 minus 3 into minus 3 is the whole square. Is that? So this is immediately given by 6 minus 3, and this is 9 minus 3 times 9. So this is exactly 3 minus 27. So this is going to be negative 24. Is that? So this is y value. The coordinates of y value when the gradient of the curve at this point is this one, the y value will be this one. So this is all about our today's lesson. Maybe